In this video, we'll evaluate the improper integral from 1 to 2 of the function 2 over the square of 2x minus 4. Take a moment to notice that it is in fact improper. When I evaluate at x equal to 2, the denominator will be 0. This expression will be in fact going to infinity as I get close to 2, and we have a vertical asymptote there, an infinite discontinuity, and we're going to be integrating up to that discontinuity. Regardless, let's carry out a substitution here to make the expression look simpler. I'll take u to be 2x minus 4, so that du is twice dx. We need to change the limits of integration. When x is equal to 1, u will be equal to minus 2. And when x is equal to 2, u will be 4 minus 4, it will be 0. And that again will be the source of the discontinuity. Let's carry out the substitution. 2 times dx is exactly du, so I have du replaced. And then the rest of the expression is 1 over u squared. The limits of integration, 1 corresponds to minus 2, and 2 corresponds to 0. And so we've changed the limits of integration now in terms of u. Hopefully you see again that it is in fact improper. If I plot the function y equal to 1 over u squared, and look at it between minus 2 and 0, I'm seeing a vertical asymptote right here at 0, and therefore we have an improper integral. So we should set it up as a limit. I'm going to let b approach 0 from the left. Again from the left, because as I move towards 0, I'm approaching it from the left side in my interval. And I need to integrate that from minus 2 to b, 1 over u squared, which is really just u to the minus 2. Let's find an antiderivative. So I go up a degree and I divide by that new degree. I'll have u to the minus 1 over minus 1, and then I need to evaluate at minus 2 to b. Let's simplify the expression in the brackets. It's going to be minus 1 over u, and then let's evaluate that between minus 2 and b. So I plug in two numbers. The first one will be u equal to b, and the second one will be u equal to minus 2. As b approaches 0, this term here approaches infinity. Notice what's happening. The denominator of this expression is going to 0 from the from the left. So this is a very small number and negative number down below. The ratio will therefore be big and positive, and this entire integral will diverge because this term is going to infinity, this term is going to a constant value of 1/2, and the limit will be equal to infinity, and therefore the improper integral in fact diverges.